Welcome to the DIY Honda Garage channel. The DTC P006A indicates a problem with the MAF sensor circuit's range or performance in the Honda Accord models from 2017 to 2023. The mass airflow MAF sensor measures the amount of air entering the engine and helps the engine control module, ECM, adjust the fuel-to-air mixture for optimal performance. This sensor is crucial because incorrect readings can lead to poor engine performance, higher emissions, or even engine damage if not addressed. The location of the MAF sensor is typically between the air cleaner assembly and the intake manifold. Additionally, this error could coincide with other potential DTCs such as P2073, T2074, P2228, and P2229, which should be addressed first if they are present. Understanding the context and implications of DTC P006A is essential for effective troubleshooting and maintaining the reliability of your Honda Accord. DTC P006A indicates an issue with the MAF sensor circuit's performance, affecting how the vehicle's engine control module interprets air intake data. The MAF sensor is crucial for engine performance by gauging the volume of air entering the engine. This data informs the ECM, allowing it to adjust the fuel delivery accordingly for optimal combustion and performance. Typically, the MAF sensor is located in the intake air duct, downstream from the air cleaner assembly. A fault in this circuit could hinder the MAF sensor's ability to report accurate airflow, leading to erratic engine behavior. Regular monitoring and diagnostics of this sensor are necessary to maintain engine efficiency, fuel economy, and emission standards. Therefore, identifying problems related to this component is crucial for the vehicle's overall health. Several factors may trigger DTC P006A. First, poor electrical connections can arise from corrosion or loose fittings, which disrupt the signal and performance of the MAF sensor. This may impede optimal airflow measurement, compromising engine performance. Second, damaged intake components, such as the PCV valve, hoses, or intake air duct, can impede airflow, leading to erroneous readings and triggering the fault code. Lastly, a dirty air cleaner can restrict airflow, further compounding the issue. This creates a cascade of problems that necessitates thorough inspections and checks. Identifying these possible causes allows for a systematic approach to troubleshooting, ensuring that necessary repairs yield effective results. When the DTC P006A is present, it typically manifests through several symptoms. One of the most noticeable is poor engine performance, which may involve hesitation or reduced acceleration as the engine struggles to find the right air-fuel mixture. Additionally, increased fuel consumption can occur as the engine compensates for incorrect data from the MAF sensor by adding more fuel than necessary. This inefficiency can lead to higher operational costs for the driver. Rough idling or stalling can also be experienced, as an inaccurate reading from the MAF sensor affects the engine's ability to maintain a consistent idle speed. Recognizing these symptoms can help in quicker diagnosis and repair, ultimately ensuring a smoother driving experience. The first troubleshooting step for diagnosing DTC P006A involves a comprehensive parts condition check. This step requires verifying the integrity of components crucial for the MAF sensor's operation. Begin by checking for poor electrical connections or damage to the PCV valve, PCV hose, intake air duct, and the air cleaner. Make sure to inspect the purge line and all parts leading through the turbocharger joint to the throttle body. Poor connections can lead to inaccurate MAF readings, which might trigger the DTC. If any components are found to be compromised, they should either be repaired or replaced before moving on to the next diagnostic steps. Completing this step thoroughly ensures that basic issues are addressed early in the troubleshooting process. Step 2 focuses on a visual inspection of the intake air duct. This component is pivotal as it connects the air cleaner to the engine's intake manifold. Check for any signs of damage, such as cracks or detachment that might allow unmeasured air into the engine, leading to incorrect readings from the MAF sensor. Ensure that the air duct is securely connected to avoid any leaks that could affect engine performance. A loose intake air duct can introduce discrepancies that the MAF sensor fails to account for. If any issues are found during this inspection, either reconnect or replace the damaged parts as necessary. Completing this step is critical to confirm that the pathway for air intake is clear and secure. During troubleshooting Step 3, it is essential to conduct a visual check of the air cleaner element. The air cleaner is designed to filter dirt and debris from incoming air before it enters the engine. Over time, the filter can become dirty, restricting airflow and limiting the MAF sensor's effectiveness. This can result in miscalculations regarding air volume, impacting the engine's performance and fuel economy. If the air cleaner element shows signs of being dirty, it will need to be replaced promptly. If it appears clean, you will proceed to the next step in the diagnostic process. Regular maintenance of the air cleaner is crucial to keep the engine running smoothly, and a dirty filter is a common issue that can lead to further complications. For troubleshooting Step 4, begin by checking the MAF sensor signal without running the engine. First, turn the vehicle to the off mode and then switch to the on mode. Using the Honda Diagnostics System, HDS, measure the MAF sensor input at this stage. Aim for a parameter value of approximately 0.2 grams per second, G per second. This value serves as a threshold for determining normal operation. If the current conditions match this threshold, you can move on to the next step. However, if there's a discrepancy, it may indicate a faulty MAF or intake air temperature IAT sensor 1, necessitating their replacement. By utilizing the HDS, you ensure that you are collecting accurate data for your diagnostic efforts, aiding in effective troubleshooting. In Step 5, you'll perform a MAF sensor signal check while the engine is running. Start the engine and vary the RPM between 2,000 and 3,000. This will allow the MAF sensor to operate under load conditions, providing you critical data about its performance during normal operation. Again, utilize the HDS to monitor the MAF sensor response during this process. The expectation is that the MAF sensor's readings should change with varying engine speeds. If adjustments aren't observed, this could indicate a need for replacing the MAF or IAT sensor 1, as it would suggest a malfunction in measuring air intake. Accurately assessing the sensor's responsiveness aids in confirming its operational integrity before proceeding with any repairs. The sixth troubleshooting step involves performing a thorough check of the MAF sensor while maintaining the engine at 3,000 RPM without load. The vehicle should ideally be in park, CVT, or neutral manual transmission. After holding this RPM until the radiator fan activates, you'll then take the vehicle for a test drive while monitoring certain parameters, including engine speed, vehicle speed, and data from the map and throttle position TP sensors. Post-test drive, the HDS will indicate the OBD status for DTC P006A. If it returns as failed, then a replacement of the MAF sensor or IAT sensor 1 is required. However, if it indicates passed, the system is functioning properly at this moment, but checking for intermittent connections is still crucial for ongoing diagnosis. The final step in this troubleshooting guide is to conduct a repair verification process. After any repairs have been completed, It's essential to confirm that the system operates correctly and to check if the DTC P006A has cleared. Utilize the HDS once again to ensure no fault codes remain in the system. Additionally, take the time to recheck all electrical connections and wiring for the MAF and IAT sensor 1. Poor connections can lead to intermittent issues that may mask underlying problems. If everything appears satisfactory, take the vehicle for a test drive to observe its performance in real-world conditions. Confirming the integrity of repairs not only solidifies the current fix, but is a critical step toward preventing future issues. Preventive maintenance is key to ensuring long-term reliability for your Honda Accord, particularly regarding the MAF sensor and air intake systems. Regularly inspecting the MAF sensor for any signs of wear or damage can help in catching issues before they escalate into more significant problems. Additionally, replacing the air cleaner element periodically is crucial, as a clean filter optimizes airflow and enhances sensor function. Furthermore, take the time to regularly check hoses and electrical connections for signs of wear, looseness, or damage. This preemptive approach not only extends the lifespan of critical components, but also maintains optimal performance and efficiency of the engine. In conclusion, troubleshooting DTC P006A involves a series of systematic steps, ensuring all potential issues are appropriately identified and addressed. Understanding the components involved and the role of the MAF sensor is critical for accurate diagnostics. Inspecting various parts and performing sensor checks are essential in diagnosing the problem accurately and efficiently. Additionally, recognizing symptoms associated with this DTC serves to expedite the diagnosis and repair process. Lastly, engaging in preventive maintenance practices not only aids in sustaining vehicle performance, but can also prevent future DTC occurrences. Following the steps outlined in this guide provides a comprehensive approach to addressing the DTC P006A in your Honda Accord. Please like and subscribe to the channel. See you next time.